Hi guys, welcome to sample 3. In this sample we are going to write a program in Robot C, and we're going to transfer that program over to our VEX testbed, and we're going to run the program on the VEX testbed. So as you can see here, I've got my Robot C open and I've got my testbed on camera, and we'll kind of flip-flop between the two today, and I just need you to follow along with me and do as I do. So let's go ahead and get started. First thing we're going to do, open up our PLTW template. So File, Open Sample Program, scroll down to PLTW template, open, and then the first thing we need to do once we get it is save our own copy. So save as, and I'm going to save mine as Mr. Warren S3 for sample 3. And I'll go to the student drive and save it in there. So Warren, where am I? Here we go. Automation Robotics, I'll save it in Mod 9A. Robot C sample activity, sample 3, and I'm going to go ahead and save into that folder. Now we can go ahead and get started. So project title is going to be sample 3. Team members are going to be, well, just you. The date today is February 5th, 2015, and section will say 9A. Okay, before we get started with our task description today, there's a couple different things that we have to do before we start writing our code. If you take a look over here at our testbed, you'll notice that it looks just like the picture when we went to configure our motors and sensor setup. So if you come up here to motors and sensor setup, and you've done this before, and go to standard models, in the past we've selected GTT testbed, which looks similar to ours except we're missing the claw. The two motors on our testbed are VEX 393 motors, and they only have 2 wires that get plugged into the cortex. So because of that, we have to make a change in the ports that they are input into the cortex. So where they're plugged in, we have to change that. So we're going to go ahead and select GTT testbed and then click apply. And then next, you need to go over to motors, the motors tab. And you can see here in port 1, we have a claw motor, port 2 is our right motor, and port 3 is our left motor. And they're all listed as 3-wire motors. We're going to change this. So I'll go ahead and delete all 3 of those. And once you've got them deleted, I want you to go to port 1 and type in left motor with a capital M, and then go to the type and select VEX 393 motor, because our left motor is plugged into the first port on our cortex. So now we're going to go all the way down to port 10, and port 10 is going to be right motor with a capital M, and we're going to select on the type VEX 393 motor, and then lastly we're going to select apply. Now our motors are set up. Luckily for us, we don't have to change any of the sensors. The line follow and potentiometer are in the correct place on our cortex, and so are the limit switch and bump switch, so none of that needs to be changed. So again, just to review, you're selecting the testbed, and then you need to make sure you have left motor and right motor input here. Click apply and OK. Alright, once you get back, you'll see that all of the sensors and motors are in the correct place. That's what all of this is telling you, what ports you have your sensors and motors plugged into. And the last thing we need to do before we move on today is to compile our program. So we'll select compile program, and now we can start writing our code, our task description, our pseudocode, and our task main. So the way today is going to work is I'm going to give you the task description, and I'll give you the first line of pseudocode, and then I'll give you the first line of the task main, and you're going to have to write the rest of the pseudocode and the rest of the task main on your own, and then we're going to talk about how to test out that program on the test bed. So let's get started with our task description, and I'll open this up full screen for you at this point so you can see. Alright, so our task description today is going to be that left motor runs at full speed for 5 seconds. Okay. Then write motor runs at quarter speed for 5 seconds. And then lastly, both motors run at, we're going to say, 3 quarter speed for, let's say, 10 seconds. Okay, so there's our task description. Left motor runs at full speed for 5 seconds. Then right motor runs at quarter speed for 5 seconds. And both motors run at 3/4 speed for 10 seconds. All right, so then let's go down to our pseudocode, and our first line of pseudocode is going to be that left motor starts at full speed. Okay, that's our first line of pseudocode. Your job now is to take that task description or that complex behavior and break it down in the pseudocode into the simple and basic behaviors that go there. All right, so take a couple minutes to do that, and you can pause the video. Welcome back. All right, so now you should have your pseudocode completely finished, and we can go ahead and start with our task main, programming what we want to transfer over to the test bed. So to get started with this, we're going to take a look at our first line of pseudocode, and we see, okay, left motor starts at full speed. Great. Let's go ahead and start there. So remember, I need to make sure that I have natural language up on my function box. And we're going to break that down and go down to movement and select start motor. Drop start motor down below the curly brace, and we're ready to determine which motor we want to start. Well, we know that we want to start, when we look at our pseudocode, our left motor. So we're going to type in left motor, and your text should read red. Once the text reads red, that's Robot C's way of letting you know, yes, I understand you want to start the left motor. For speed, it's full speed at this point, so it's going to be a value of 127. Okay? So now you need to go ahead and continue programming the rest of your code all the way through. And then when you're done with that, come on back and we'll talk about how to transfer the program over to the cortex. Okay, now that we're back, you should have your pseudocode and your task main completely written. The task main that I have up on the screen is a sample task main. Yours should not look like that. It's not the same program. I'm just going to use it as an example of how to transfer the program over to the test bed. So let me minimize my screen here so you can see the test bed. Here it is. And once we have our program written and we're ready to transfer it over to the test bed, all we're going to do is come up here to the top and select Download to Robot. And once you select Download to Robot, it's going to show you the download progress. Now sometimes this will not work correctly, and you might have an issue like I have here where it's telling me, hey, your VEX Cortex is not turned on. They're right, it's turned off, so the program can't transfer. So in this case, what I'm going to do is select OK, and I need to come over here to my Cortex and make sure that it is switched in the on position. There are other times when you might have the Cortex have an error because the USB cable is plugged into an incorrect port on your computer. It gets a little finicky sometimes. Sometimes the USB cable likes certain ports on the computer rather than others. So if your program won't download to the robot, then you need to go ahead and just try another port on the computer, okay, another USB port. All right, so now I'm ready. I've got it turned on, and I'm ready to go ahead and download to robot. And it should download correctly this time. And then the debugger comes up. If you have any errors in your code at this point, you'll have red X's over here that'll indicate, hey, something's wrong. The computer can't read what you've written. And you can go back and you can fix it. When you're ready to run your program, you're just going to hit Start. and the program should run. In this case, we expect to see that the left and right motor both run at full speed for 2 seconds and then turn off. So let's take a minute and see if it works. Great, so we've transferred our program over to the cortex. It now works, and we can see that we have written a correct program. So if you have any questions in class, please let me know. If you have any trouble with your program transferring, please refer to your Robot C information sheet or talk to me. Please remember to save your file in the correct mod and in the correct sample folder.